Well, hi, and thanks for joining me here in my shop. Hey, I'm getting a bit of a late start here this morning, but nevertheless, now there's two things I want to talk about before I do anything. One of them is the last test I did at the end of the last video, where I'm looking for a little bit of movement in the meter here, and then there's adjustment to cancel out that movement. So when I performed the test, there was no movement. But rather than just say, oh, that's great, I went ahead and fiddled with the control that you're supposed to adjust to achieve no movement up here when you're flipping the switch. And that control appeared to do nothing. So I'm kind of wondering what that's all about. There was something else that's not coming to mind just now. So let's look into this first question. What exactly is going on here when I'm performing that test? Let's see if we can sort out why it is that the adjustment would have no effect. So here's the schematic here for the beast. The part we're interested in is right in here, this part right here, P4. Let's zoom in a little bit on that. P4 right here. So you see it's a potentiometer, one leg open, so it's just like a variable resistor is what it's being used as. It's in one leg or one plate circuit of this rectifier tube. From then on, I can't say much at all about what is going on here. It goes into these complicated switches. This is the same, this is like a back and front or two wafers on the same switch. This tube is hooked up to a transformer with two secondary, really three secondaries. This one's just for the heater, but look at, there's one here and there's one here. Relating the circuit diagram here to the actual unit is very difficult because there is no key that helps you understand exactly which switch this is. Here on the schematic it's called S6B, S6A, and there's no way to figure out, directly through something in this manual is exactly which switch that is. So by deduction, actually counting the number of switch positions and thinking about where this switch is physically located relative to the transformer and the tube here, I think I know which switch this is. This is the switch that's called plate shunt. It has 7 positions. 5 of them have resistances marked on them. 30K, 20K, 8K, 6K. The last 2, F and G, have no resistance associated with it. I think those resistors, yeah, you see, I can't explain this. I'm going to give up already. I'm going to give up because it looks more like this would be it. This would be it. I don't know. So you see, I can't even figure out which switch this is. That's how difficult this unit is to sort out. So, but this is definitely the resistor I was adjusting, and you can see the meter sitting right here, and you can see outputs from these 2 switches, if I can call it that. Yeah, off the, oh my god, off of here. Oh my god, where's it going? Whoa, okay, it's coming in. I don't know. See, I can't do it. I'm one lost puppy on this. If we go from the meter back, we see this is the meter reverse switch. Comes out of here. It goes into this meter switch. The meter switch has 5 positions on it. Right. So, God help me. Okay, never mind all that. Let's get back to this. What is this doing? So they've got a potential up to a 500 ohm resistor in this leg, but they got nothing in that leg. But the thing is, this part is connected back kind of through this part, this secondary part of the transformer. This one is hooked up to, I think, this one. So I don't know what they're doing here. But I do know in the manual it lists. Let's read it. Let's read it. Where is it? Okay, we gotta go hunting. Let's go hunting over here. Hunting. What am I hunting for now? I'm hunting for a listing. We'll find it in a second here. It's coming here. Plate voltage switch D. This is the switch I think we're looking at. Somewhere in that area on the schematic. And look at this. You put it in G, you get 160 volts pulsating DC to the plate. Use with GM. You put it on A, you get 20 volts AC, 50 volts AC, 160 AC to the plate. So as much as we might be used to feeding nice, smooth DC voltages to the plate of a tube and the like, yeah, I guess in the tube testing environment, it's not absolutely critical that you use DC. You can do things with AC. So, 300 volts AC to the plate. So going back then to the schematic, what I think is going on, I should have just done this. What I think is going on, oops, as soon as I can get there. I can't remember what I think is going on. It's like the room effect just from staring at my computer screen and seeing different images on it, I guess. So it's kind of, yeah. So one of these is producing, I guess, the DC side of things, and the other one's sending AC over. I don't know what's going on here. I'm really lost. But what about this 500? Why would it be? So this test is done with a temporary resistor installed somewhere in here. I couldn't tell you where, but somewhere in here. The 2000 ohm 10 watt resistor. And that probably makes this circuit work entirely different, and probably makes this work different. What if I don't have those resistors hooked up properly? What if I stuck the 2000 resistors into the wrong spot, and that negated the function of this? At least in the test I'm performing. You know what? That's possible. I have made mistakes in the past. I gotta check that. Let's check that right away, and we can eliminate that as a problem. So just reading where that's installed. Temporarily attach a 2000 ohm 10 watt resistor from ground, which must be in the chassis, to switch to position 1. You know what? I do have it in the wrong spot, I think. Because there's another spot in here where you take a... yeah, I better go take a look. Let's see if I got this in the wrong spot. Switch to... I think I put it on position 2. Switch number... Wait a minute. Switch number 2, number 1. Switch number 2. Oh, I followed this. Number 1. Why am I thinking I did it wrong suddenly? I'm just making synaptic connections in my brain right now and try to sort out why I'm thinking what I'm thinking. Why did I say number 1? Yeah, it's just bad memory. Yeah, I did confuse this with another thing I did where I hook up to the center post. Oh, well, let's see what I really did. Oh my gosh, maybe I... Okay, let's look and see. I bet you I did this wrong. To the test switch. You can see my resistors right there. Let me look again here. I've done something terribly wrong, maybe. Switch to number 1. Switch the test switch. Switch to... Why would I even bother looking here? Here we are, switch 2. So I'm looking to see if there's some proximity between this and that, you know, on the diagram here, no, but electrically they could be next to each other. And it says 1. And sure enough, 1 is kind of, looks like it's in the middle here. 1, 2, 3, 4, 5, 6. And 1, 2, 3. Okay, let's using this to identify which is pin 1, I will now compare. So it's 1, 2, it's 4 from one side, and 1, 2, 3, 6th from the other. 4th and 6th. 4th and 6th. 4th and 6th. 4th and 6th. Fourth from one side, 1, 2, 3, 4. You can see where the resistor is really poorly connected there. And from the other side, it's 1, 2, 3, 4, 5, 6. So the only way I got this wrong is I counted it completely backwards. That's certainly possible. So the switch in the so let's see. Let me just set this if I can. Make this camera sit here. There, stay put. Perfect. So did I get this mixed up? And I still have it now. That, yeah. What a filthy looking switch too, huh? Is it possible I got switch problems? Frankly, I have not noticed a single switch problem in here. These switches are going to be of a sort which were selected because they would not give trouble over time. Even though they look filthy dirty, it may be wise to leave them as they are for now, until I have some positive indication of trouble with the switches. I had a little bit with those slide switches, but you know, there's lots and lots of switches in here. I start fooling around with them, they could generate more trouble than benefit. Which is usually my thinking. Okay, so let's look at the schematic here. Oh my gosh. So how could we ever identify this is one or this is it? Not here, Jim. Up and over where there's a diagram right here. So this is clearly looking from below. Oh my gosh, I think I have it connected here. So looking from below, switch 2. Oh, that's right, that's in the camera view. Okay, so we can do this. So I'm sure I've got it on the wrong one then. I've gone and flipped it around. I've got it here. 1, 2, 3, 4, this way. Okay, switching to the camera view now. Okay, now it's rotated around quite differently. It's 4 counting that way. Let me just peek here myself. Oh my gosh, you know what? It's I got it in the wrong spot. It should be 6 counting from that yellow wire at the bottom there. It should be 6 over. Let me just, yeah. Yep, I blew it. Okay. We know what's gone wrong now, so I'm going to move that wire, the resistor wire, to where it needs to be. Oh, son of a gun. Son of a gun. Okay. Well, you know, that's actually really good news. You really should not be disappointed having found my mistake. I'll work right in here. Just flip it right over. Okay, right in here, went way up here. What a dummy. 1, 2, 3, 4. Yep. Oh! Hold on. 4 and 6 are connected together there. Hold on a second here. I did not make a mistake. I seem to remember, I don't know if I mumbled about it, but I remember seeing this wire. It's just it ties them together. it's really soldered there. I think I just have them twisted here. I should probably solder this back. And then that's definitely the ground terminal. That's soldered there. May not be the greatest, but it's definitely soldered. And how do you know that's the ground terminal? You follow that wire. Tricky to see, but that end terminal right there that we're looking at is connected to the chassis under that screw. The other way of knowing is because it says up on the panel top, ground. It has the ground symbol. You can actually see it there, the ground symbol. So I got this connected right, and perhaps this didn't work. Bad chance. My experience is, you know, that's good enough. But I will. We're going to have to repeat this test. Now, what if I thought I was adjusting P4, but in fact, I was adjusting something else? So 4, I think, is up here. It's up here. So you can see I've numbered it already, 4. What are the chances I got that wrong? Oh, really, really low. Really low. So that's 4. What are the chances that adjusting it, you know, the plate current is flowing through this thing? So if this were not making contact inside, something would be seriously amiss with this tester. How do I know it's not amiss? What have I done? I've done a GM test. I think I've done an EM test, and clearly quite a few different circuits are used in these different tests. So maybe I have not employed all the circuitry in here yet to discover things that aren't working. So what I'm going to do, I'm going to repeat the test quickly. I'm going to remove those resistors and move on. And I think in the meantime, I'm going to twist these more firmly. I really don't need to solder them. I mean, really, there's just no way that's not conducting. It's too bad, man. I've gone from, hey, there's my mistake, to I don't know what I'm doing again. Okay, let's flip it over. What's happened there? Nothing's happened. Go. Okay. All controls counterclockwise. Test on the meter. Test on the short setting. Off here. And we want to watch the meter closely. I'll put the camera there again. Watch it very, very closely. There we go. Ah. Okay, sit there, Mr. Camera. So there's the pointer, machine off, and it's been sitting all night. So I'm going to flip the meter switch to line, so we can do the line adjust once it starts up, which I think we're okay to do now. I think everything's ready to go. If I remember, I leave this thing on too long, it seems to overheat with those resistors in there. Here we go. Okay, we gotta switch it on here. And now we'll apply power. Remember, it's set to line, so it's heading over to the line setting. Okay, full power. Whoa. Give it a moment here. In the manual it says you should give it 30 seconds before proceeding with things. Seems pretty fixed in place now. It's hard to believe the line voltage is that steady in my house. Oh, there, it moved a bit. Hey, well, what if I do? What if I just turn a light on or off here? Yeah, it's an LED light. I don't think that's gonna do much. Let me turn on some heavy piece of equipment. I've got nothing that's gonna load down the. Yeah, I got nothing here that's gonna turn on my vacuum cleaner. Okay. Okay, everybody, cover your ears. So, you know what I'll do? I'm going to kill the sound here. We're going to flip on the. Okay, that did it. I guess that proves it is actually seeing the line voltage there. Now, the test, because everything's heating up here. The test. First, I got to adjust this. Get this right on the money, if I can. There. Okay, line adjust done. That's bias reading, which you don't care about. And now this is the test. The idea is I flip this the test switch itself into test mode, and that pointer may or may not move. Last time I did this, I was shaking the thing. Let me put the brake on my little rotating table here. Here we are. Okay, ready? Well, it's absolutely no movement. Okay, so we go back to trying to adjust P4 and see what effect it has. Getting my tool in there. Okay, I think I got it. Wait a minute. It's easy in this particular control to get the screw. See that? I shorted something briefly there. There, I'm in. Okay, now the idea is I put this onto test mode, and then I turn this control all the way. That's full range. That's 500 volts going, or 500 ohms going in and out of the leg of that thing. Oops, yeah, I fall over too. Okay, off and fully off. What do you think of that? What do you think of that? Precise. I don't know what to make of that. My only option is to continue on. I can't sit here and spin my wheels forever. So that's what we're going to do. We're going to carry on. What I'll do with the 2000 ohm resistor is I'll disconnect it from the ground here, but leave it for future use. I'll disconnect it from there. And I went ahead and soldered it on, so we'll unsolder it. So this doesn't leave me with good feelings. You know, I do remember now what the other thing is that's got me a little worried. when I tested the first 6C4 in here, just a little tiny smidget of worry. Every time I turned the unit on to perform the test, the unit behaved like there was a short circuit in it. Well, as it turns out, by using another tube tester, the tube itself had a short in it. This raises an interesting question then. If you have this unit set up to test the tube, and you have this in test mode, which I think is where you would normally start, it'd be sitting in test mode. The moment you put a shorted tube in, you now have the short in place, potentially damaging your tube tester, which is the concern with a shorted tube, until you knock this off one setting. Now I'm guessing once you have it in the short setting, if your tube is shorted and this is either encountering the short or not, in either case there's no risk to the tube tester. So what this is suggesting to me is that when you're starting with a tube that may have a short in it, and most tubes may have a short in it, you should put it in the tester only after this has been set to at least number 1. It's taken off the test mode anyway. And I don't think it says that anywhere in the instructions. So yeah, just a little bit of concern about that. How did I manage to discover in another tester that the tube was shorted? Well, the fact is, with this set in test mode and turning it on, it was obvious there was a short somewhere, and because I'm in the middle of trying to fix this thing up, my assumption is the short is probably inside the machine, not in the tube. It's funny how your brain thinks, at least how mine thinks. Really humorous stuff. Now, let's just pull this right off here. Should be easy to get this off. There we go. And then because I didn't solder these two together, take this guy off here. Now I got this thing sticking out. I'm going to bag it. I'll just put a little bag on it. We'll just leave it hanging here for now. Why am I doing that? You know what? I'm trying to save myself a fraction of a second. Let's take it off. Chances are I'll never put it back on. I'm thinking I want to leave it on because I'm going to come back to this test at some point. But if that's the case, then I'll put them back on. Okay. Gotta be flexible. Gotta be flexible. Gotta be rethinking everything. Gotta have doubts about everything. So now we're ready to go to the next stage. My assumption is that the last thing I was doing is okay. Let's look at the next stage here in the calibration. So we've performed the plate bridge balance. That's what we've completed. Turn power off, remove the resistor, which I did. So now we're starting the GM adjustment. Set front panel controls for 6C4 as shown in diagram A. Insert the tube and turn the power on. 6C4. Okay, you can do that. 6C4. 6C4 is right here. Okay, 6.3, this is off now, isn't it? It's actually switched on, but it's not plugged in. Switch it off. So no surprises, 6.3. I love that knob, that's a great knob. EGGG. E, just bringing in place a 3K resistor. GGG, GGG. And then there's just a dash. This is why I'm not familiar with this control, because it's a vernier, it's a potentiometer. 40650. 40650. 12000. 12000. What were those doing up there? Oh, son of a gun. I thought I looked at all these and made sure they were turned down. That may have thrown off that whole thing I was doing. That's what I'm concerned about. Bias set to 4.8. Got to do that with the running. The GM should be 1300. Shorts found on 1, 3, 4, and 5. So we'll take our 6C4. We'll put them in. Get in there, buddy. Now this is the good one. This is not the blown one. I bent a pin on the shorted one to make sure I don't get mixed up. So double check very quickly. 6.3 E GGG, doesn't matter. 40650. What have I done here? You know what I did? The numbers that should be set in here, I set them in this row. What a dummy. Now I know. Oh my God, what an idiot. Okay, double check it. I think maybe I should start triple checking, in fact. You double check after you think you have it right. So every time you think you know what you're doing, that's when you need to check in order to find out you don't know what you're doing. Put this on line to start. Okay, let's double check again. E, G, 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 doesn't matter. 40650, 40650, 12000, 12000. I got it now. 4.8 volts. We're in the 10 volt range. You're ready now to start them up. 6.3. The tube is in place. Switch is off. I'm going to put the switch out. Put the switch on. It's just a beautiful machine. What a crummy on-off switch. Couldn't they have come up with something a little more exciting than that? You know, they're trying to balance it here against this switch, I guess. You know, make it look. I mean, this is a nicely balanced instrument. There's no doubt about it. Got a nice look to it. Power on. First, we're going to put on the dim bulbs. Wow, they ever come in bright at first. So that's probably just the heater through current. I mean, this tube's in there too now. Okay, full voltage. And the line is actually a little high. 124.4 volts today. I don't think that tube's heating. Huh. What? Let's carry on. Okay, line adjust. Okay. Bias. We want this to say 4.8 on the bias scale. We're just about there. There we are. That's 4.8 on the bias scale. We're now into test mode. What are we supposed to do at this point? We're just supposed to test it and read the GM, I'm pretty sure. 1300. What does it say in the manual? Let's just take a little peek at the manual here before I make a mistake. Rotate short switch through all its positions, return to test. Short neon bulb should only light in 1, 3, 4, and 5. The short test light is lit in 1, because I had this sitting in 1. That may not have been the best. Remember I was talking about that? So, but no problem. If there's a short in there, I see it's heated up now. If there's a short in there, in this mode it's a problem. But in this mode it would not be a problem. And the numbers were, once again, 1, 3, 4, and 5. 1, 2, 3, 4, 5, and then no more shorts. A little flash doesn't mean anything. Can we go right around? We go right around. This is a spot of nothing. That's interesting. A spot of nothing. Maybe this is where you leave the switch neutrally, sitting all the time. Test mode.
So now we're going to attempt a test here. Isn't there a meter? Yeah, meter scale is here. Bias, just for bias. Meter scale just for bias. Isn't there another? Maybe not. So we're going to go to test mode and we're going to try to see 1300 on the GM scale. Okay, so there's a couple of different GM scales here. So one goes from here. Since we're getting all excited about the meter, let me just get a little camera shot set up here. What if we look at it sideways? Is that going to cause a lot of headaches? People going to get injured looking at this sideways? Probably what will happen is I'll probably fall over. Okay, so we'll take a look at that meter sideways here. That's terrible. We can't look at a meter like this sideways. Okay, I have, because of the parallax problem with looking at it in the, so this is not sufficient. But I have more than one ways. More than one ways. I have multiple grammar. There we go. So what if we take my airborne. 1 second here. Oh. All kinds of complications I'm not talking about on the video. Mostly tangled up wires in my shop here. So we can position this like this, and you should get a good look at that meter now. Okay, well, it may not be the best look right at the moment. Let's slide this here. And make sure I'm not sliding the unit into anything live. Put that down like that. There's a view. Hey, that was worth getting. Now let me see if I can focus it. And the answer is no. Without explaining what I'm doing, I have to do something here to enable the focus on that camera through the video software I'm using, like this. Okay, now we've got a bit of a hot light here. That's better. Beautiful. You can see that from this angle, the meter is actually writing slightly below 0. Yeah, after doing other adjustments, it's not so wise to come back to this very first one. I just didn't quite see what I was doing. I'm turning that little mechanical zeroing thing. That's beautiful. Now that's a 0 worth writing home about. We're ready. So the tester's on. All I got to do is throw it in test mode, and then we want to read on the 2 GM. There's a 2 GM scale. So which one would you read on? Hey, that's a really good question. How do you know which scale to read here? I can see this better in the camera view now. Let's see, one is, there's all kinds of scales. Oh, I know how this works now. 3, so if you look at the right hand side, you see 3, 6, 8, and 20. 3, 6, 8, and 20. And that matches the resistor values marked on the plate shunt control, and we're set to 3. 3. So if you look at the 3 scale, I believe this is what we're trying to do here. It's pretty weird because it says 3K. It's just a funny coincidence that the value of the resistor showing on the control matches the scale range. It doesn't quite make sense to me, but maybe that's just how they arranged it. That's why I think there's a meter scale control, because it's this plate shunt control. Okay, so what I'm talking about is this control right here. So you see it's on. Why is the short light on? What? Why is that light on? It's not on. You know what that is? That's sidewards light coming from this bulb over here, coming through it. The short light is not on. Okay. Back to this. So there we are. So we take the 3000 ohm marking there, and we just pretend that it's also the scale for this. So we're on the 3. So if we're on the 3 and we're trying to get to 13, then that would be, let me just point to it here, in my mind, 13 is going to come up right in this range here. Oop, no, it isn't going to come up here. It'll be, right here. There, that one. Okay, I can't think of anything else. Let's hit the switch here. Here we go. What is the GM? So the GM, I'm holding the switch here. In fact, it's got a hold button. Just snap it on hold. 1500. The jumping around a bit. What's all that? I'm not moving a bit. That could be in line voltage variations. I'm looking at the, so 123.6, 0.7, 0.6, 0.7. I can't watch the meter up above and the meter down below at the same time anyway. So we could attribute that variation to just line voltage variations. I mean, there is a little bit of variation going on here, but I'm afraid I can't look at both at the same time. Tiny amount, 0.1 volts out of 125. That's not much. So, question is it really 1500? Or is this machine totally bogus? 1500. The only way to know is I don't know how to know for sure. The best way to know would be to take independent measurements of the current flow and voltages involved with this tube and make your own external calculations around the measurements you took to determine what the transconductance is. So transconductance is a kind of a funny number. It's the variation in voltage on the grid in volts divided by the current flow at the plate in milliamps, and that forces the GM number to come out in thousands, tens of thousands. So that's why this is 1500. It's 1,500. In fact, look, can you see what it says? GM in thousands. It says it right there. And I guess the usefulness of this number is that when you get used to it, and I'm just starting to get a little bit used to it, the GM quickly allows you to relate how much amplification the tube can produce. So, for instance, I'm going to get this right. I'm practicing, okay? Let me not get this right. The GM of 10,000 for every volt change in the grid, you get a change of, help me now, 10 milliamps in the output. I don't know. I guess maybe the GM is dependent upon the external circuitry too a little bit. Would that be the case? I don't think that's the case. Okay, got lots more to learn about what GM really is and exactly how I should have it parked in my brain so I can make quick, intuitive use of the value. Other than just looking at a tube tester and going, hey, it should be 22,000 and it comes out 21,000. It's a bad tube. I want to go a little further with that. Okay, so we've been staring at this for quite a while and kind of see what the meter does. Almost certain that's line, yeah, the line just dropped down to 0.4 and back up to 0.6. So I'm quite certain those are line voltage variations you're seeing there. I'm also assuming you can leave this thing in GM mode essentially indefinitely, and so I'm going to take it off. jam mode. We're going to test that tube in another tester, and all these testers are really to be considered questionable. Let's check it out. Let's check another one out. Okay, let's give it a try. I pulled that right out of that other tube tester, and it wasn't even hot enough to be uncomfortable in my hands. It's just nicely warm. Didn't this tube glow like a son of a gun in this tube tester? We're going to find out in a moment. So the tube tester's off. Put the tube in. 6.3. 2. 20H. 20 high. 3076P. 307G. It's not a 6. Oh, look at that. 6 and G. You can get those confused. G. P. That's correct. 5100, 5100. That's why in countdowns you'll hear people go 10, 9, 8, 7, 6, 4, 3, 2, 1. They won't say 5 because in bad communications, 5 sounds like fire. So I've actually heard that number get skipped on a countdown. I've actually heard somebody do that. 44. F. Now this one says the reject point is 1430 on a GM test. This one also tests one plate than the other. Wait a minute. P1 and P2. What's going on here? I got the wrong tube. 6C4. P1 and P2. What's up here? There's no question it's a 6C4. Why is it acting as if it's got 2 plates? I'm seeing things. 6C4, right? No question. P1, P2. So P1, P2 means plate 1, plate 2. Something's not right here. This is not making sense. 6C4. How can I have P1, P2? 6. Okay, so what is it? I don't know. 6. I thought this was just a simple amplifier tube. 6C4. Power triode. Well, you know, there's two plate. So you know what they're doing here? They're simply checking the 2 terminals that are tied to the same plate. So you're able to check from this terminal or from that terminal. It's not that there's 2 plates. Okay, I can calm down. Whew. That really had me going. Here we go. It must have been the 6X4 that was glowing like a son of a gun here. And that makes sense. The rectifier tubes need to pump a lot of current through them, so they tend to have very hot filaments in order to help the flow of electrons leap off the cathode and fly through space. Okay, short check. Test on the GM. Question is, well, let's see. Look pretty closely now. So 1000 would be here. 1300 would be up around here. 14, where it wants it, is way up here. I got nothing. This just gives me the worst feelings. 2000. Yeah. Check the line. Check the line. Check the line. Line's right on the money. Gee. Sometimes the switch doesn't go. Sometimes the socket doesn't make contact. Tell me I've got a dead tube here. This tube is freezing. So when you put a tube in, the pilot light usually flickers. And no flickering there. What, this tube died on the way from one tube tester to this one? The tube was assassinated by the last tube tester? You know what, it wasn't very hot. I wonder if it literally burned out under the test, and that's not good either. One thing I have not done is I have not double checked the filament voltage in any of these. Oh my gosh. Yeah, this is why people like you like watching my videos. You kind of never know what the heck's going to happen. Neither do I. We'll leave this set there. We'll put this back in here. Put this back online. This is in the test position. Power this guy back up. It's amazing how different my shop looks in the camera view. With my eyes, this is really quite dark in here. You can kind of see my hands are a little fuzzed out there from slowed down. I think anyway, the camera slowing down to compensate for the low light. But it's just amazing how different it can look. Okay, short test. I'm watching this light, which appears to be on. There, now it's on. 1, 2, 3, 4, and 5. That's correct. Those little pops don't matter. Test position. Offline voltage. Bias should be set to 4.8.
Let's look with the good meter here, the good camera.
Very, very good camera. So now I want this to be 4.8 on the bottom scale here. You see the 4. It's just right on the 5. So I'll put it down to 4.8. There's our 4.8 bias volts. Okay, off bias onto test. And now run the test. So reading, because we're on the 3 scale, the 3 scale, we come over here, is exactly 1.5 again. This tube's working over here. You can see the heater in it. I must have. Okay, power off. Got a consistent result. Get over to the other guy now. And I'll go back and try him again. Because okay, I gotta go through this again. 6C4, 6.3. I got socket problems here in this tube tester. Well, it's coming on the bench soon. They're all getting onto the bench. 220H. How could this be wrong? 3, because I'm not seeing it right. 307 GP. That's not a 6. 307 GP. You know, it's correct. 5100. 5100. That's correct. 44 on the meter. F. Okay, it should be 1430. We should get 1430. Now, I'm watching again for the light to flicker. Why in heaven's name? Unless the socket is shot. Isn't that terrible? You know, I need another tube tester. Okay, let's give this guy a guy. Now this is my baby here. This is the tube tester that I've relied on. I've had this guy for the longest time. So first, 6C4, 6C4, right there. There we go. Another tube tester. 6.3. What was that doing on 7.5? JR. On this tube tester, these first two settings are the heater settings. JR. So at this point on this tester, with the voltage set and with these two set, you can pop a tube in and carry on. But I won't. 6307. So now we go 6307 with a 0 on the end. 24. You know, this one, I think I pointed this out last time, this one also labels all these. I've never really noticed. Suppressor, cathode, screen, plate, grid, filament. Actually, it's filament right there. 24 on the bias. 24 on the bias. 75 on the English. That's to make the good bad work, if you want it that way. P4 expectation here is 1385. So we've had 1430, 1300, and 1385 declared as the lower GM limit for this tube. Now, whether those numbers are varying because the testers work differently and ultimately they are riding at the same functional point with the tube, or whether this is what these people claim. This tube is good down to 1385 and beyond that, you shouldn't use it. And this is a foggy question. How good or bad the GM should be on a tube before you reject it. It's definitely an issue. So we'll plug this guy in. Plug him in. Okay, switch on. On this tester also, you're free to move these controls as long as you don't have one of the test buttons depressed. So you can fiddle around all you like. You're not actually applying any voltages to the tube until the button's pushed. So let's try the line adjust. Why not? Since we're really into this these days. See, I would never really bother with this kind of stuff because I'm never really looking for precision. As I did the line adjust after the tube is in and the filament current has settled down. Short test next. See, the tube is heating up here, so in my other tester, something bad is happening. Short test, and we're looking for the short light here. Flash doesn't mean anything. Actually, a flash is a sign of a good tube. Now we're going to push the GM test, and we're going to want to read at least 1385, 1385, pretty much straight up on here. We're on the 3000 scale. Yeah, 1385 going to come just below the little question mark. So it's way up there. So an actual reading of GM in here would be 2000. So the GM in this tester is 2000. The GM in the other tester is 1500. And the man with two watches never knows what time it is. See, the man with two tube testers never knows what the GM really is. So if we rely on the good bad, and just flip it like that and push the button again, good. Certainly good. So one of the things I hope to do as I go through these tube testers, all these are going to be on the bench. All of them are going to get worked over. All of them are going to be, I'm going to try to bring them up to proper function, and then I'll be able to compare them all. And I think one thing may be true. None of these testers are all that accurate. Ever were, ever could be, ever will be. And as long as you have one, you feel pretty good about the results. But as soon as you introduce a second tester, or in my case, I have 5 of them. I actually have acquired 5 tube testers in here, for crying out loud. Well, we're going to find out what we're going to find out. I think that's the end of the road, or were we supposed to? No, you know what we're supposed to do? We're supposed to adjust this back so it reads 1300. But shouldn't we adjust it so it reads 2000? Yeah, I don't think, wait a minute. Calm down, Jim. So, GM adjustment. Stick in, all he did was stick in the two. Rotate short test, repeat CD, rotate meter to test, note reading on 3000 scale. Without changing any settings whatsoever, rotate plate switch to 6K. Oh yeah, so you know, this is a crazy way of doing this. So I read this over. I can explain what, oh my gosh. So what they say you should do, in light of the fact that you don't have a standard to measure the GM, you don't have like a standard absolutely for sure tube with a fixed absolutely for sure GM. So it's basically the instructions are suggesting the next best thing. Take a good tube, 6C4, GM should be 1300. Is that what it said in the manual? That's what it says on here. What does it say in the manual? So it doesn't say in the manual. What it does in the manual is it says take a reading, in my case 1500, write it down, 1500, change this to the 6, to a different scale, from the 3000 scale to the 6000 scale, see if it still reads 1500, which would be down here now. Adjust it to make it read 1500. Go to the next scale, adjust it to make it read 1500. Of course, you're moving down and down the scale. And the idea is it reads the same on all scales when you're done. Well, supposedly it's reading correctly on all scales, but you could have just done nothing more than adjust them all out of whack the same way. Let's fire this guy up again. We'll do this. Online. These repeated things help me to get more and more comfortable with operating this machine and my other ones too. So I don't mind kind of repeating things quite a few times. By the time I'm done with all these machines, I want to be expert on all of them. And I want to know, you know, this machine tends to do that, and this one, you can skip doing that test with it because it's bogus, or whatever it is I might find out about. Line adjust, we're dead on. Bias 4.8, it's pretty darn close. Bias adjust. 4.8. Test. Oh heavens, I left this in hold mode over here. Oh, that's dumb, eh? But I guess as long as you don't have these other controls in test, this one maybe doesn't matter. So wait a minute, what are we getting up here now? Check the bias sensitivity here. Watch the meter movement. Let me put the other camera there. Oh, here it is up here. Yeah, flying camera. One sec. Let me just use our flying camera here. Okay, so now instead of getting the 1500, I'm now getting like a 16 or 1700. What have I done? So I want to do sensitivity on the bias because I moved the bias a bit. So I'm just going to, what's with the focus on the camera there? Okay, moving the bias just a little bit. Hey, what's going on there? Did you see it jump up and down? Right there. What was that? I'm just moving the control smoothly and slowly. Right in here, there's a dirty spot in the control. Or bad connections. Let's keep turning it. So I'm turning up and up the bias voltage and driving down the tube. Well, I don't know. We're supposedly measuring GM. What did I just see? Did I see something flash? I don't know what happened there. I thought something reflected in my glasses. I'm freaked out doing this kind of stuff. So putting the bias back to where it should be. So meter on bias. So where did I get the bias to? Oh, I drove the bias way up here. How come the meter's stuck there? What's that? Look at that. Whack! What's going on? Whack. There's a sticky spot in this meter. Whack. Can I blast it past it? Ooh, it almost got stuck there. Okay, let's put it up against it. Give it a little more juice. It's really stuck. Now I'm going to tap it. Boy, oh boy. Back down. Look at it. It's stuck. Oh, there it goes. Wow. This is bad. This is a bad thing. Right there. Right around the 16. I hadn't noticed this before. Oh my gosh, what would cause that? You know, things like the pointer rubbing against the glass. Has the glass fallen in? Sometimes the glass can fall in. I did notice there's a crack right here. Doesn't feel like that. Doesn't feel like the glass has dropped at all. Oh my. That's really disappointing. It's stuck there. There it goes. There's not a lot you can do about a meter movement, you know. So thank God it's sticking high in the good. Really? Well. Okay, back to where it's supposed to be. 4.8. Driving this tube nuts the whole time. GM test. That's a GM test right there. It's back to the 1500 mark. Line voltage 123.6, but I checked that using the line adjustment. So why was it up a moment ago? Whacking the tube here. Very, it's really screaming out 1500, buddy. That's what it is. So I'm just looking everything over in case you're wondering why I'm so quiet. These meter switches are a little wonky, but if anything, they would tend to drop the reading. Let me shake the switch over here. So that's a reversing switch there. Yep, seems okay now. Okay. Yeah, I don't like this. Oh yeah, you know, I forgot what I was doing here. That's right, we're going to change scales now. Right. Oh, what's going on? What happened there? Of course, I'm wiggling this around to make the pointer move a bit. What was that? As far as I know, the line voltage didn't vary. Any one of these switches could be dirty. Any one of them. So let's start with this one. I don't want to wiggle it too much. Or maybe this one. This is the GM switch. Or maybe this one. Or maybe this one. Test switch. I just want to wiggle these a little bit on their contacts. I don't want to actually make them switch. That would not be good. Hey, this one seemed to do something. I don't know. This one here. I'm gambling these switches are all excellent. Oh, what happened there? So I probably moved this one a little too far there. That's probably what's happening there. I'm doing nothing and it's just jumping up and down. The line voltage appears to be steady according to my little meter. So who's jumping up and down here? Keep going through, got a couple more to wiggle. What else could be wiggling? Could be this bias thing again. So I'm wiggling the bias just a little wee bit. That would wiggle it more there. How do I know the bias? How do I know when I set the bias to 4.8, it's actually 4.8? Have I even gotten anywhere near testing that kind of stuff? I don't think so. Okay, scale change. So 1500 on the 3 scale should cut in half. 1500 is here. So very exactly now, I'm going to use the bias to move this right to 1500. A little bit of cheat. Come on, don't jump. Right there. Change scales. Wait, where'd it go? Come back. I can't, something. There we go. So that says 18, I would say that's 18. And going back. Oh, what happened there? When I went back, I got this reading. Huh? I'm trying not to move. What's it doing? I'm going to tap a bunch of stuff here, including the tube. Oh, something moved there. What was I tapping there? I'm tapping the actual control that changes scales. Let's just do this a few times. Huh. What just happened? The whole thing just disappeared. I'm just going back and forth between 2 settings. This is not good. What did I do? Did I bump something? What has happened? Oh my gosh, what happened there? So just kind of give an idea of what I'm doing here. I'm sorry it'll be a little out of focus. Doesn't have to be out of focus. I can make it focus. I have the power. I have the power. If I choose to use it. So that's all I'm doing. Look at that. Someone's at my door. Hang on a second.